we see that we're integrating a product here, and integration by parts can be thought of as a reverse product rule. It does work for lots of other types of integrals, but it will often work for products. And we need to choose a u and a dv. And I will choose u to be x, and I will choose dv to be the rest of the integrand, so e to the 4x dx. Now, you could have swapped those if you wanted, and if you did, you would find out that the integral gets more difficult. So sometimes trial and error is necessary. In my mind here, I see that when I differentiate x, the power is going down. Power here is 1, the power here is 0, x to the 0. So in the end, we're going to see that that's going to make our new integral easier than the old integral. Now, when we integrate e to the 4x, we get itself divided by 4. So that's using the reverse chain rule. I'm going to call this integral omega. And so now we're going to let omega, the integral, be integration by parts, ultraviolet voodoo. We're going to do u times v. So u times v will be 1/4 x e to the 4x minus the integral of v to u, the voodoo part. So uv minus integral of v to u. And that's the bottom row. And what I want you to notice is that this integral here is easier than the original. So that's what tells us that we're on the right track, that we've chosen the correct u. If we would have swapped out those functions, you would end up seeing that this coefficient would end up being x squared divided by 2, and it would be more difficult. And anytime that integral ends up being more difficult, you've got to go back and choose a new u. All right, well, let's finish this one off. So we're going to have 1/4 x e to the 4x. This integral here is an exponential. The integral of an exponential is itself divided by the divided by the derivative of the exponent. So we will end up with that as our final answer.